The only difference is one step at the beginning and one step at the end. Okay? And so the rest is really just multiplying what we talked about in 4.2. Okay? So if you look at this first example here, and I'll talk through sort of the structure of dividing. Okay? When you're going to divide rational expressions, what you're simply going to do is you're going to treat just like what division is. Dividing is equivalent to multiplying by the reciprocal. So what we're going to do is we're going to invert and multiply anytime we're being asked to divide rational expressions. Okay? So if we take our first fraction and we leave it exactly as it is, but if we invert and multiply by the second fraction. So the second fraction, we take what was the numerator, 25 times z plus 9, and we move it to the denominator. And what was in the denominator, we move up to the numerator. Okay? Once you get to that step, then you just go through the process of multiplying. So multiplying is factor everything completely, and you can do that in the same step as inverting. Okay? And then cancel common factors. So here the z plus 2's cancel. 5 goes into 25, leaving 5. And so when you look at the numerator, we're just left with a negative 1. The denominator, we have a 5 and a z plus 9. Okay, so this would be our simplified form. Okay, I had mentioned that the two differences were the beginning, you invert and multiply, and then at the end, it has to do with the domain restrictions. Okay, and when you look at domain restrictions for a division problem, you have to still account for the same restrictions you have from multiplying the factors. So any canceled factors from the denominator, okay, you have to restrict those values from the domain if they're not apparent in the simplified form. Okay, but then in addition to this, you also have to take into consideration any factors from the inverted fraction that did not get canceled but still remain in the numerator. Okay, so if you look at the inverted fraction, it's the numerator. Okay, and if they don't cancel, you have to restrict them as well. And the reason for that is when you invert, so like this right here, this z plus 2 was originally in the denominator of its own fraction. So when you invert these, what winds up being up here in the numerator was originally a denominator. So if they get canceled, you're going to see it from the first rule, the canceled factors. But if they don't get canceled, then you have to restrict them because from the original fractions involved in the problem, it would have been a domain restriction. All right? So we'll take a look at some of those here in a second. But in this example right here, when you're looking at it, I'll kind of use this to sort of gauge. I circle the denominators as well as the numerator of that inverted fraction. Okay, so in my denominators, the canceled factors here were z can't be a negative 2. That's not apparent in my simplified form, so I include that. And there's no other canceled factors. There's no factor in the inverted fractions numerator that didn't get canceled, and so that's my only restriction for this problem.